Hello everybody, if anybody watching this. So I'm starting again. This project is a real project in IBM Cloud Pak for data. So here we are making a prediction system. Here's our prediction model. Currently we're working with several features and we have a target. Basically all this is for defining whether a counterparty in our market will go bankrupt in this period or not. So we have basically a binary classification problem, and the result of our model is a prediction score. So for each counterparty you will end up with a prediction score, whether it will go bankrupt in the current month or period or not. So if you've done a lot of work in Kaggle, you are used to have a good data sets. In real life, well, it doesn't happen so often, and the main struggle in real life projects is a data preparation thing. So we have a huge number of different data sets, and you eventually end up preparing it to extract features, and this part is the most interesting and, well, hard in all this process. I'm going to to do something with new data that I have, and in following hour I'm going to extract some data from I think some data. Well, where is it? Counterparty regions, probably now, not LDF, just the lookup. Well, is it here? Well, let's look at this. And if I want to say something about the data pack, well, it would be short. So first of all, it's a nice thing to have. Well, I used to learn generally working with machine learning on Jupyter, and end up developing it in Visual Studio Code if you want to make a solid output. But IBM Cloud Pak is a thing for a team. Currently I don't have a big team. We're working it for this project with my partner, and it helps us because we can understand who created each data set. We have different notebooks which we can let the access to each other. Overall, for each notebook there's a kernel that is created by this data pack thing, and it's not that huge. It has like 2 GB of RAM, but you can set up some provisions if you need to expand the memory. It could be done. So I've worked in this for several weeks already. Well, it's pretty interesting. Well, it's a good product. I didn't pay for it, but as I know, it helps a lot, you know. You can do projects here, and if you are used to work on Jupyter Notebook on your own PC, or maybe on a server that you have, well, you can do it here. It also supports PySpark. As I know, I never used it here, but well, still it's doable here. So well, let's proceed with doing something. I wouldn't talk much, as you know, the programming of these things. Well, you have to be concentrated on different things here. Okay, and once again, when you're building a big project, it's very important to make some notes. My notes are in Russian, in Cyrillic, because my partners and well, overall this work is for a Russian company. So but if you do something in notebooks, making notes is a must, and also making tests is a must. Currently, this is a early stages of production of this model, so it has little to none tests. They're manually, but unit testing and well, integration testing in machine learning production is crucial. It didn't happen in Kaggle much because, well, you have only one task and it wouldn't be expanded after the task will be completed, after the challenge will be completed. But in real life, your ML products would be updated or moved from one platform to another, and this is crucial to make tests. Okay, so let's look at the data. Yeah, this main conjugants, well, DB, okay, this is a little bit stupid, but name for this data asset, but it still works. This is not what I wanted. They might have, you know, the real life is you have a lot of data that is useless, and you really need to understand what could be helpful for your model, and to extract it from huge heaps of data. Well, this thing, I've already worked with this. What's this? Mouse.dep. This is the new version of this. Yeah. So eventually it will end up for making each day these files, but it would be in a stream. It could be done with like these connections and different connected data, and if you have a server out there, well, the data could be transferred to this system, and well, it works, but not now. Eventually we are working currently on this, and we need to patch up this IBM Cloud Pack to be able to get this data from Oracle servers. Well, it could be done, you know. It's just a matter of time, and I'm not a server guy, so I'm waiting for this specialist to came from vacation and to complete this task. But I cannot stop the work, so we are currently working this with these CSVs, which are like a mirror for a current data set that we are going to retrieve from Oracle in further. Okay, a copy of all this is a output data frames made as a CSVs, because there's an interesting part. You have to, well, I think that you have to partially have different notebooks for each type of ML flow. If you if you are preparing data, well, this is crucial to have it in a separate notebook, because data could be large and well, it wouldn't be enough to have 2 gigabytes for a data preparation notebook. And if you are making a model after it, well, it's not good. And you have to have some rules for your data output. For example, we have a rule that it should begin, the columns should begin with our target column, in which we have 1 or 0 for each classification, and well, the rest of the columns are features that could be expanded in time, but we also know how to make slices for our model. We always know that the first column is a target, and it is sliced for our trainix and trainee grid. Well, several words about the model. It's XGBC classifier, the standard thing for now. We're not going to make any complex modeling here, and you know, it's rare to make complex models, because there are some top managers out there that will look at your model, and they will ask a lot of questions, and if you can tell them in simple words what are you doing, well, it's beneficial for this task. So when your model has like something like this, where you can tell these guys and suits that, well, you know, this feature is important like in this numbers, and this feature is important in this number and in this number. Well, the random forest thing could do it even better. So, well, it's really interesting to make this model. It's simple. You have a negative log loss. You can make it just log loss, it doesn't matter. It's like 1 minus. And the score is AUC, AUC. So we have like CV is a cross validation. we have 3 faults. For cross-validation, we are making a grid search for parameters to understand, and we are having like this, something like this. So I've done this several times, so something between 75 and 125 estimators for this model is okay. I have not done a grid search for a depth. There is a parameter. Well, there is a thing that will let you dive deep in this classifier. Well, where is it? Learning rate, steps. Yeah, max depth. So it's 3 for this model. It's okay. If we rebuild it, for example, well, let's look at this. It's not okay. Let's make it happen. Let's rebuild the model. Here's the startup for this notebook. It is granted. Yep, something happened. Sorry, one moment. I'd like to check things happening in real life. Sorry. That. Okay, everything is all right. Let's proceed. So, what did we have? There was a yeah, the max depth. Okay, let's look the grid search for max depth. Something like, I think no, one is, it's not good. Okay, let's expand it. And building rate 0.1. Okay, I don't think that we need this. And okay, where's the graph? The graph is here. So like 75. Okay, let's rebuild the model from now. Yeah, let's restart it and make it from scratch. Yep, the model is building. Oh, max depth. Max depth. Focus. Okay. Yep, we have 36 feet, not much. Yep, you need to wait. Well, max depth 3 is better. Okay. It doesn't change. Okay. Max depth Not much, not much. So I don't really understand. But here, the thing is that we have a score that the delta is uh, is increasing as we increase the max depth. Well, what about the prediction? We have two. It's really well. Eventually, it's the same. It's the same. Yep, it's the same. Don't know why do I have two outputs. It's very interesting. Yeah. Okay. So the max depth for 3 is wonderful. You don't need to make anything other than that. It doesn't really help in many tasks. So let's proceed with that. Yep, we're good. Okay, let's make it another run just to make a good. So I'm going to change this 0, 200. Yep, and restart. So, what can I tell you? Something else. If you wonder what things could be helpful, first of all, is this cheat sheet. I think could be useful when you're working with your ML projects. I'll try to find it and paste in maybe in the chat. Let me look at this. So if you have essential cheat sheets for machine learning, well, if you're really interested in this thing, this could be helpful for sure. Because I personally don't remember all the syntax for many tools that there are in machine learning. For example, when I was working with PySpark, I was very confused with the syntax, and I didn't want to remember in details everything. So this cheat sheet that I pasted was very helpful. Also, with the Stack Overflow and the official documentation. But well, yeah, Stack Overflow is very good. Okay, let's look at this again. Again, you see that 125 is okay. So you have a boost, a real good boost here. Then you have a little increment in score, and then you have your model overfitted, and well, it's not good for your model. Yes, of course, you have a plateau on train, but the test thing, well, drops. Okay, so now I think the fun part is over. Don't know why do I have like the doubling. It usually happens when you have two kernels so you need to really kill the kernel and restart it. If you have something in your Jupyter notebook mirroring, this bug is that you have two kernels. The previous kernel is not killed or something like this, and you have variables running twice. So yeah, it's for sure that you have to kill the kernel. Okay, anyway, I'm not going to make anything in modal. The fun part is over. The prediction part is interesting. Well, it's like gaming, you know. You're trying to create a better model. You're trying to make the score up, and when you play games that, well, you can watch on Twitch, you know, it's very fast. You do something, you increase your score or anything like this, but in real life, it's not that fun. And for increasing this score, you have to well to do a lot of work like this, like making new features, filtering things, and so on. So, for example, each counterparty or firm has a legal address and a postal address, and currently my partner made a table. We retrieved an index for each company. This is the zip code. Yeah, the zip code was had been retrieved for each company, and and what had happened? So the big thing is, like, you have doubles when each company changed the address. So the zip code was changed too. And now we need to filter or make a ledger for these changes to extract the real thing, the real index, or extract the index for each time frame, for each year and month in this table. And you have to write code for this. It's like this. So this was a real quick overview of the current work that has been done, and I will make some increments, and I'll tell you and myself about the work that I'm currently involved in. So thank you for watching.